Hello and welcome to another video. In this video, we're going to be doing maximum number of operations with the same score 2 from the bi-weekly contest 124. This is basically a continuation of the easy problem with just more constraints. So in this one, you're given an array of integers called nums, and you can perform any of the following operations that contains at least 2 elements. So you can choose the first 2 and remove them, the last 2 and remove them, or the first and the last and remove them. The score of the operation is the sum of the deleted elements. Your task is to find the maximum number of operations that can be performed such that all operations have the same score. Return the maximum number of operations possible that satisfy the condition mentioned above. So in this first one, they show you that you can delete the first 2, you would get 5, so delete these 2. Then we can delete the first and the last and get 5, and then we can delete the last 2 that are left and get 5. So we have 3 operations here. And in the second example, you can do 2 operations, or you can do 2 things. So you can get rid of the first 2 elements with a score of 5, and the last 2 elements with a score of 5. So you get 2. So this is very similar to the easy problem, just a little bit harder, obviously, or I guess significantly harder. So for the easy problem, you can just check like what's the score of deleting the first 2 elements, right? So we can say like, okay, this is 5, and then we can try to delete the next 2. Is that 5? Is that 5? And so on, and we can keep doing that. This is very similar to that, except you don't know what your first operation is. So let's say these constraints were really small. Let's say these constraints were like kind of small. It should be pretty easy to figure out that you can do like a DP problem here, right? And your DP problem would just have like a start index, an end index, and like a value that you're trying to get, right? So for example, we can say like, okay, let's start here. Our value can be like, maybe like anything or something in the beginning because we haven't done anything. But let's say we choose to delete these 2. Then our value would be 5, right? That we try to get from here on in, and our constraints, our left and right, would be these. And then we can just figure out like, okay, let's try to do any of these operations. Can we get a 5? And if so, then let's do that. But the problem is you can't have a start and a value because your constraints are 2000 and numSi is 1000. So if you were to use all 3 of these constraints, right, the start, the end, and the value you're trying to get, like the value you're trying to get all the time, this would be too big. So we have to eliminate something. We have to eliminate either start, end, or value. And if you look, you can only do one of these 3 things. So let's just think about, like, let's just look at our starting array. So this is our starting array. If we can only do one of these 3 things, how many values can we really try to match? Right? Like that. So we have to get the maximum operations that's such that all operations have the same score. But we can only start with 3 operations. So let's say we do like these 2, then our value would be 5, right? Like if we delete the first 2, then our value everywhere else would be 5. If we delete the first and the last, then our value would be 7. And if we delete the last 2, then our value would be 7. So you can basically just run a DP on this using a first and last value, and you'll have 3 starting conditions. So let's kind of walk through this example here. So let's say our array is this, right? So 3, or we can actually even draw it in. Okay, so let's say we have this starting array. And let's say we have 3, 2, maybe we can even add some more numbers, 3, 4. Let's just add some more numbers. So like 6, 8, 9, 1, 3. So essentially, as I was saying, you can only do 3 values at the start, right? Either delete the first 2 or the last 2 or the first and the last. So let's take a look at all of these. So if we delete the first 2, we're going to say, okay, we're deleting these 2. Our value is 5, and our start and end indices are right over here, right? If we delete the last 2, then our value is 4, and our start and end indices are right over here. And if we delete the first and the last, then our value is 6, and our start and end indices are, so if we're deleting this and this, our start and end indices are right over here. And so we will pass in 3 values to the DP, but the reason it will work is because the value we're passing into, right? We're going to pass like a left index and a right index and a value, but this value can only be one of 3 values. Basically, we're just going to perform the operation once, each one of these, and then run the DP on the rest. And so what's that going to look like? Well, let's just run an example on this 5. Like let's say we do this 5. So we're going to say these are the first 2 elements. So we're going to call DP with these 2 indices, right? Because this was deleted. So we're going to say 2 and index 9, and the value will be 5. And every single recursion of this DP will have this 5. This 5 will be the same. So even though you have 3 values, the constraints are only actually the left and the right. And then basically from there, it's pretty easy, right? Like if we can fit the value in, then it's really easy. Like we have a left and a right. So what's our cases? So our base case is we don't have enough values, right? Like we don't, like we only have, like let's say we only have like 1 value left, or like our left and our right are too close to each other, or our left is like greater than the right or something. In this case, we want to just return 0 because we can't do any operations. Now another base case is we're going to try all 3 of these things, right? So let's say this is our subarray. We need to try to get a 5. So we're going to try like the first 2. Okay, well, we can't do that. Let's try the last 2. We can't do that. And let's try the first and the last. So that's kind of like another base case is can't recurse anywhere. So we can return 0 there as well, right? Because we can easily just like, by doing our bounds, we can just check like, can we recurse? We will only recurse to like legal positions to minimize our state. So we can just check like, are the first 2 elements possible? Are the last 2 elements possible? Are the first and the last possible? If we can't, we'll return 0. Otherwise, just return max of all. So I guess this won't be the base case. This will be the recursive case. So the recursive case will be max of all possible moves. So if you can do something, then try to recurse. And let's say our value was, instead of 5, let's say our value was 4, just to give an example here. So we can get a 4 by deleting the first and the last element. So the recursion there would be pretty easy. It would just be DP. We are deleting these 2 elements. So then our left is updated to be over here. So our left would be 4 and our right would be 9 and our value would be 4. We can also get rid of the first and the last. So if we get rid of the first and the last, then our new left would be up here and our new right would be over here. So also pretty easy. So it would just be 3, 8, and the same value, 4. And then you can also do the last 2 values here. So the last 2 values would be these 2, and then your end would get updated. Your left would be the same. So it'd be 2, 7 with a value of 4. And then every time you have a valid recursion, you just add 1 to the result because you did make 1 move. And that's basically it. So we're just going to run this DP with our 3 possible starting things and see which one of them gives us the best thing. And then we got rid of this. We're basically getting rid of this value because the value will only be one of 3 values. So we can take a look at the code for this, and it's pretty straightforward. So we have our DP. And basically, like I said, so I have a start and an end instead of left and right, but it's the same thing. So if we don't have enough numbers, let's return 0. Then we just have our 3 conditions where like, can we get rid of the first 2? If we can, let's recurse there. Can we get rid of the first and the last? If we can, let's recurse there. Can we get rid of the last 2? If we can, recurse there. Otherwise, if you weren't able to make it to any of them, then you just return 0 as a default. And then this is where we try all of our starting conditions. So we're going to try to start with removing the first 2 elements, get a value there. Then we're going to try to start with removing the last 2 elements, get the value there, and remove the first and the last element, get the value there. So we just run this DP 3 times. And so the time here will be O of n squared because we have a left and we have a start and an end, which can be close to any number in the list. And the space will be O of n squared, even though we have 3 variables here, because like I said, values can only be one of 3 different values based on this section here. We will always just pass down the same value we had. And we can run it. I think you can probably make it more efficient by making it bottom up. I'm doing way too many problems today to do that. So this is just the basic idea for that one. Yeah. And yeah, it's going to be all for this one. So not too bad. And I'll just do the last one in probably like an hour or 2. I'm almost done with it. I just have like a few more bugs. It was like significantly harder than what I thought. Maybe there's like a better way to do it, but yeah. Yeah, if you did like this video, please like and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.